Welcome back. Another day of Terraform. So, first, I want to cover everything that I already covered yesterday, just to, get back into the what do they say? Into the groove. Is that too nerdy? Is that outdated terminology? Let's do a quick 1-2 and get through all this stuff. Okay, so we started here. I need to get this off my screen. What, doesn't get smaller? Maybe I'll just do it like that. Maybe it's here. Okay, so this is where we started. What is Terraform and why do we use it, and also how do we use it? So basically, Terraform, as you know, is a program for infrastructure as code, and it's something called a declarative model. And basically, this declarative model allows us to define exactly what we want to build instead of indicating like the exact steps that we want to take to build something. So instead of being like, okay, let's say you want to build a car, instead of being like, we need to put the engine in, but we need a frame, and then we need to put the wheels on, and then we need to put the doors on, and then we need to blah blah blah. Instead, from the start, we say, I need a platform with a body, with engine, with wheels, with this, with that, with all these different configurations, and we say that at the start. And then what happens is Terraform builds it for us, and it's also very consistent and maintainable because we manage it the same way we manage code, which is kind of with Git, with state management and version control, which is really important for enterprise delivery, because we don't want to like end up with something called like shadow IT or something like that. It's like, for example, you always hear these stories about when one person gets like fired from a team, and like you realize like that one person was fixing so many things but nobody knew about it, and so now everything is like on fire. So that's kind of like the concept that we're talking about. Now, the reason we use this declarative model and we version control it is to ensure consistency, repeatability, and statefulness across our deployments. And now, specifically in Terraform, the language that we use, as Terraform is created by a company called HashiCorp, we use HashiCorp language, also known as HCL, and we use this to write the Terraform file. Now, when we talk about the Terraform file, we're talking about this .tf file, and basically that's what we use to actually provision resources with this declarative model. And the state file also uses the same language, but we don't write the state file. To create a TF file, you just make a file, .tf, and then you start typing in it. Now, when you want to apply your file, so to speak, which is typically provisioning those resources, you're going to use tf apply. And when you use tf apply, it also does tf plan. And this is where we have to get more into the state file. So when we have our Terraform state file, we basically have a bunch of metadata, and it's not written by us. It's written by Terraform, and it basically maps resources to IDs, identifies dependencies, and it has all the instance names, and it contains everything about the desired state. And we use this TF plan. Well, it's kind of optional depending on how you look at it, but when you run Terraform apply or TF apply, it automatically does TF plan for you. However, we want to do TF plan because we want to be proactive and we want to really manage the state and manage our Terraform, be a good, DevOps engineer and do our due diligence. But you basically do TF plan, and what it does is it queries the current state of the architecture and it compares it to the state of the architecture that you want to get to, and it calculates a diff. And so it says like, okay, well, this is what needs to change. And so it creates an action plan in order to implement that. Now, along with this, there are certain scenarios where you have, let's say, a really important service. And, let's say we have two DevOps engineers. And these two DevOps engineers, one of them wants to, TF apply the changes that he made. And so when he goes and does that, what if he deletes something really important that was really critical and should not be deleted, or replaces a part of the infrastructure that should not be replaced? And so there are certain controls that you can put into place to prevent that from happening. And so with TF apply and TF plan, that's kind of what we're talking about. Now, after this question, we moved on to what happens if a state file gets deleted. So in an ideal scenario, if your state file gets deleted but it's version controlled, you can kind of just roll back. And so when you roll back, you'll find the previous state of your architecture, and you can just, use that to then go and, recreate or reprovision your environment. But you don't want to just run TF apply, because it's going to create a bunch of conflicts, and your infrastructure is already running, but your state file is gone. And so with no state file, you run into a lot of issues. And so it's really important to take good care of your state file and protect it, because if you do lose it, you need to re-import everything using TF import. And so when you write all the resource blocks manually, after that you can use TF import to basically tell Terraform that you want it to recreate a state file based on all this information. And so how do we import manual resources? Basically use TF import. You write the resource block with current information. A lot of the time, the resources that you're using are not going to be native to Terraform, so to speak. And so, for example, use AWS or GCP or Azure, and all these different cloud providers. They have different resources, and so you need to use these provider APIs with Terraform. And so if we have the resources that were not created by Terraform, but we still need them, we need to bring them in and make it stateful. So we do that by using TF import, which maps existing resources to configuration blocks within our .tf file. And so this brings orphaned resources under control, because we didn't necessarily provision them, or maybe they were provisioned before. And so we want to control these resources within Terraform. Now, back to our state file, we want to protect our state file. And so how do we protect the state file? Well, we basically do it with version control and state locking. And so the way that we do that is we protect the infrastructure from being deleted, overwritten, which prevents conflicts. And so we want to create something called a secure remote backend. And so one way of doing this is by taking your state file and putting it in an S3 bucket and enabling versioning and protecting it so that if something happens, you can roll back to a previous state. And we also want to use IAM to really protect that bucket and enable encryption at rest, where information is secure. And then we also have something called lock-in, which is really important. So just having your state in a protected S3 bucket with good IAM and good encryption and all that good stuff, it's not enough, because if that's there, people can still go and try to deploy a bunch of stuff. So it's not really stopping anything. And so for that reason, what we like to do is use a DynamoDB table to lock down the state file. And so that the purpose is that if you have two people that are both trying to deploy or TF apply, what's going to happen is that if they do it at the exact same time, while resources are being provisioned or while things are still loading up, only one person is actually going to be successful and the other is going to fail. And so the whole purpose of that is to prevent this kind of conflict. It's kind of like if two people are trying to merge their code, there's a reason why you don't just merge to the master branch in GitHub, right? So it's similar concept. So yeah, that's how you protect the state file. And then how do we reuse the same configuration in multiple environments? So we have dev, test, and production. Of course, we don't want to have 3 different versions of our Terraform file for these 3 different stages. And the reason why is because, of course, we want whatever we're working on in dev or testing to be eventually elevated or graduated to production. And so what you do is you basically use input variables to indicate specific needs for each environment, like the instance size, like the region settings, like naming conventions, and then you basically leverage Terraform workspaces so that you can use one Terraform configuration file for everything, but you can have separate files per each environment, which makes it really easy to go back and forth without having too many conflicts. So that's what we covered so far. Now, what I want to do now is I basically just want to cover the rest of these questions that I have here, and I also want to like do my best to kind of organize things in a way that is logical so that I can reference this later on. I'm just gonna grab all of that. Okay. By the way, shout out to the DevOps dude. I did not come up with these questions. I've been watching one of his videos, which did a fantastic job of basically just getting through, all these different scenarios. But my goal here is to map it out on one page. And, of course I can take that video, transcript it, throw it into Notebook LM or Gemini and be like, make me a diagram. But like, that's not the point. The point is to do this by myself in a way that I can understand, in a way that I think is logically constructed. And it's also good for me to deepen my understanding of Terraform and also create a somewhat referenceable YouTube video to kind of, help anyone who's trying to learn this stuff learn it quickly and easily and efficiently. And you can learn a lot really quickly if you have the right resources, and that's really a critical factor. So, where did we want to take this? Kind of like even out these are like spider legs. What should I call these? Spoidar. This can go like more here. Okay, so I'm gonna pull up that fantastic YouTube video. I wonder if I type, what was that video called? Terraform interview. Yeah, Terraform. I think it's this one.
Hello everyone and welcome back to the channel.
Hello DevOps dude, thank you for this fantastic video. So I'm gonna put this here. I'm also just gonna quickly check. All right. All right. So, let's start with managing Terraform in a multi-person team.
How do you collaborate on Terraform projects with a
So if you need to collaborate on Terraform projects with a lot of people, where did I put that question? Right here. So how do you collaborate on Terraform with a large team? So
same Terraform configurations and never rely on the local state file for anything mission critical or production related. Instead, use stored state file in a remote backend such as AWS S3, Terraform Cloud, or Azure Blob, so everyone can refer to the same authoritative source. And also ensure that state locking is enabled, which prevents two team members from
answer to this question, how do you collaborate on Terraform with a large team, basically just comes back to protecting your state file. And protecting your state file means you're going to... Wait, how do I make like a curvy? Press curve. So you're basically... Oh, how do you... Oh, okay, I see. That is not a... I'll take it. Okay, it's not that bad. So yeah, well, if you want to collaborate on a big team, on Terraform, it needs to be stored somewhere so that everyone can, you know, reference the same file, and it needs to be locked down so that, you know, two people can't work on it at the same time. So these are essentially the same question. Protecting your state file is pretty much the same. Yeah, so it's kind of like a write-off of a question. Oh, did I move that? Yeah, I did. HashiCorp Terraform. How? Create before destroy, prevent destroy in production systems. I have no idea. I haven't really seen that before. So let's find out how to approach this.
Instead of going through Terraform, you'd explain that in a well-controlled environment, you ideally restrict manual control. How do you create before destroy and prevent destroy help in production systems? You answer by explaining something like this. These two lifecycle arguments are incredibly useful for managing critical or long-lived resources in a safe and controlled manner. First, create before destroy instruct Terraform to provision a new resource before tearing down the old one. This is especially important for
Okay, that's pretty logical.
high availability environments like rolling out a new version of an application server, because it ensures the replacement is fully operational before the existing instance is decommissioned, thereby minimizing downtime. On the other hand,
Okay.
the second
So basically each of these are, you know, Terraform modules. So
prevent destroy
sorry, that is not right. It's not a Terraform module. What it is
these two lifecycle
a function, Terraform function. I don't know why.
managing
Why is my text like so small?
in a safe and controlled
It's really crazy.
create before destroy instruct Terraform to provision a new resource
Create.
before tearing down the old one. This is especially important for
It just
updates
doesn't get bigger. I don't get it.
like rolling out a new version of an application server, because
Um,
it ensures the replacement is fully operational before the
what's the
existing
issue?
instance is decommissioned, thereby minimizing
Hello,
downtime. On the other hand,
Excel.
the second argument, prevent destroy,
Can I
is
go
all
bigger?
about safeguarding crucial
It does not
infrastructure
seem like
that
it.
you never want to lose by accident, such as a production
Alright.
record. When this attribute is set on a resource, any attempt to
How
destroy
to
it
make
triggers
text
effectively.
bigger? X color draw.
This not only protects against human error or misconfiguration, but also demonstrates to stakeholders
If the preset sizes are too small, you can manually scale the text box dynamically using your mouse. Yeah, but only the box gets bigger. Is this like a glitch? Like, am I just stuck in some kind of maybe it only works for like certain fonts? I'm trying to debug this on the spot. Yeah, no, this doesn't get bigger. because you have to like only make text create before destroy. And this can get bigger, and then I have to draw the box around it, which seems kind of dumb, but that's fine. So create before destroy, pretty self-explanatory. Basically what you want to do is can you make it smaller too? Both? Right. So this is basically used to manage long-lived resources, and so it instructs Terraform to provision the new resource before terminating the old one, so that the replacement fully operational before decommissioning. So as I mentioned before, sometimes you have a resource or something that you don't want to delete, right? Because sometimes people delete old stuff and then shit breaks. So basically prevent crucial structure deletion, termination. So any attempt to destroy triggers an error, prevents misconfiguration, protects critical resources. I don't like how this looks. Why is it so like weird? Maybe this is better a bit. Pretty happy with that. So let's say we need to delete a specific resource. So what we can do is we can basically use Terraform destroy target, and then you give the target. See why it's ugly now? I should have put more tabs. Yeah, that's better. Boom, 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 boom. Partial decommissioning. instance.
You want to highlight like never
And then
to hack code
protecting secrets. So if you want to protect secrets,
or commit such data to any kind of version control system. Instead, you explain that environment variables, hash buffer, or clouding solutions like AWS Secret Manager or
right?
are far safer.
So basically there's two main options. One is going to be orange with an orange background, which is AWS Secrets Manager, which is actually a red font, and my text is still not scaling up. And the other one, which is actually by HashiCorp, which is let's make it white just because it's not like a command. HashiCorp Vault. So these are your two bread and butter secrets managers, and one of them is called Secrets Manager because it manages your secrets. Basically,
Set them at runtime, so Terraform treats the input as variables and never exposes them in logs. In some workflows, you install the
let's actually ask Gemini. Compare Secrets Manager AWS to HashiCorp Vault. Let's see what it says. So, of course, AWS is AWS native, cloud native. Low effort, limited dynamic secrets. So you probably have to change things manually. Only workloads. So you can only use AWS for AWS, which kind of makes sense, but also like that's a bit too proprietary for me. Whereas of course, HashiCorp Vault is cloud, not cloud native, cloud agnostic, just like Terraform. And so basically any platform can be used. Don't know what's going on with my tabbing here. What? Whoa, whoa, whoa. Cool. So it's probably a bit more hands-on. Oh, interesting. That's really interesting. Self-hosting and management. So that's probably like them saying like, we don't want to be liable for your secrets. Like, you handle your secrets. We'll give you the tools to do it, but it's on you at the end of the day. Dynamic secret support, multi-cloud, and it's on-prem because secrets should never be in the web. So it's kind of like two different philosophies to protecting your information. What other questions we have? Okay, we have blue-green deployments. Let's go with Terraform versus Ansible because from what I understand, Ansible is more for like configuration management. So Terraform is for resource provisioning, whereas Ansible is for application configuration management. So kind of different purposes here. like I have something in here about this. No, I don't. Okay. Tell me about Terraform versus Ansible. So Terraform basically for servers, networks, security, groups. Ansible is more for the package management, services, deploying applications. Got a bit crazy there with the typing. Ansible, package management, services, deploying applications. So like, can I separate the color of these? Purple. No, I can't. It's okay. Let's Control X this. Control X this. Let's look up the Ansible color. Does it have a color? Okay, it looks kind of red. So we're gonna go with red. Bring it back to, no, it's gonna look like that. Whoa, these all became like separate words. So weird. It's okay. So yeah, this is what Ansible is for. Whereas Terraform is of course for resource provisioning. Now that we know this, how do we use this in practice? Right, so Terraform, of course, we have TF apply. I might even grab it from here. Duplicate it.
The necessary EC2 instances of virtual machines. Then in a separate stage, call an Ansible playbook that installs software, configures services, and handles application deployment. This division keeps things organized.
Okay, the fundamental difference is Terraform is for provisioning infrastructure and Ansible is for configuring that infrastructure. Interesting. So resource, let's change it up. Let's say infrastructure provisioning. For Ansible, we'll say infrastructure configuration. Package management, services. Let's make these match. So when we use our TF apply, we're basically saying like, okay, now we have a server or a network or something. So infrastructure is basically deployed, right? Terraform builds the roads, pipes, electrical supplies, empty shells. Ansible goes inside, install the furniture, paint the walls, ensure everything's. That is a horrible analogy and it's not really clear up anything. However, what we do see is that Ansible does follow more of a like step-based approach to configuration, which is interesting because that is exactly what we don't do with Terraform. So I wonder how come it's like that. Like why do things like that when Terraform is different? I guess it's on a case-by-case basis. Let's make this like that. Yeah, so that's Ansible. So step by step. I don't know why I'm like stuck on this. It needs to look good. It doesn't look good. It's gonna upset me. Here. Alright, so I'll take it. So we have a two-step process. We deploy our infrastructure with Terraform, and okay. Let's add to this. Stateless, step-based, mutable. Tell me about how Ansible figures the software and such. Right, so you have something called a playbook. So we have Ansible playbook. Again, the text is really small and I can't change it, but it works with this one. Oh no, it doesn't work with this one. Why would they do it like that? Ansible playbook. Right, so we have Terraform apply, creates our infrastructure, and then we can use a playbook. Push-based, task-driven model. Unlike Terraform, which is constantly comparing the world to a state file, Ansible executes series of procedural instructions against target machines, bring them into a desired configuration. Idempotency. Every module is designed to be idempotent, meaning you can run the same task 100 times, but it'll only make a change if the current state doesn't match the desired state. If engine X is already installed and running, Ansible simply reports okay and does nothing. Interesting. So if you do TF apply 100 times, you'll end up with like a disgusting environment that will like be completely broken. But if you do that with Ansible, you'll be fine because it knows how to deal with that kind of repetition, you could say. So then let's do like the infrastructure deployed, and OS hardening software. Application configuration. So yeah, you basically have number one. Oh, why is that? So then one. Okay. To make circles instead. 1 and 2. 1, 2, 3. Oh, blue. And let's just go like this. Two-step process to deploying infrastructure and designing application software. Everybody 1-2 step. Okay. I'm reaching the point where I can't zoom out anymore. Yeah, so this question was a write-off. And we have this guy. Okay, let's move this more in. Make things a bit more local. Oh, what there? Should have been a web designer. In the middle. Yeah. how to test Terraform code. Let's get into that one. Release readiness. So of course we want to check syntax and formatting. Linting. So how do we test our Terraform code? Okay, so we have some Terraform commands. Let's make it purple. Hooray, purple, purple. And I'm also going to use an actual text box because they don't scale. Not scalable. So we can do TF-FMT. Let me type it out, it looks better. TF-FMT, which, oh, that's for formatting actually. And I'll duplicate this text. You can do Terraform validate. Terraform validate, which is going to validate the syntax, formatting, and then we have kind of more of a, it's not a command. I mean, it is a command, but it's a linter, which is a whole other thing. But you can basically do, I'm going to do tf-lint, but then I'm also going to put tf-lint in caps, because, yeah, I'll do like this actually. So the linter, what they do is they basically look through your code and they check for like very specific issues. So let's see what it says here. So Terraform FMT ensures your code follows HashiCorp's formatting. Terraform validate checks if your configuration is syntactically valid. Syntactically valid and internally consistent, checking for missing variables, mismatched types, invalid syntax. And then tf-lint is a specialized linter for Terraform. There's linters for all kinds of different code, and so it basically catches cloud specific issues, or in this case Terraform specific issues. But then we also have none. So this is like how to test Terraform code, and then I'll also add a pipe, and I'll write how we secure Terraform code. And so if that's what we want to get into, so this is how you test Terraform code, but then I'm might just duplicate this over here. I'm gonna say multiple security tools. So there is something called Terraform compliance, and then we have something called Chekhov, and then OPA, policy agent. So Terraform plan is also testing, but I think there's a lot of stuff that it's not gonna cover. But let's see this. Oh. So, got a phone call. But basically, if you want to test your code, you can do syntax with Terraform validate, formatting with Terraform FMT, and you can do linting, which checks for like cloud specific logic. And then if you want to, make sure everything's secure, there's security tools like Terraform compliance, like Chekhov, and open policy agent. And so these are all different tools that you can use to make sure that your code is tidy. Now, we still have 1, 2, 3, 4, 5, 6, 7 questions. Let's go for CI/CD because that's a really big one. CI/CD integration.
How would you integrate Terraform with a continuous integration and continuous delivery pipeline? Here, we explain that you typically store all Terraform configurations in a version control repository such as Git. Every time a new commit is pushed, a CI/CD pipeline is triggered, starting with Terraform init to download the required provided plugins and prepare your working directory. Next, you run checks like Terraform validate to confirm your configuration syntax is correct. Some teams also add linting tools or even security scanners like Chekhov to catch style or compliance issues early. After your configuration is validated, you produce an execution plan using Terraform plan. This plan outlines the resources that Terraform intends to create, modify, or destroy, and your team can review it, often requiring a manual approval for critical environments like production. Only once the plan is approved does the pipeline proceed to run Terraform apply. This actually provisions.
So you basically need to put your Terraform stuff in Git, which that makes sense to me. It's pretty normal. And then when you make a change and save it, your pipeline gets triggered, and you can create an execution plan. So it's going to pull your code from the repository, lint it, format it, validate it, security scan it, and then you have to basically review the plan and then merge it into the main branch, and then after that Terraform init will happen. So I'm going to say put the steps in order, simplify. Trigger CI/CD pipeline. I'm gonna put that there. So let's make these in boxes. So first we're gonna validate and test, where we're gonna do tf-fmt, tf-validate, and then use Chekhov. To make it blue. And then after you validate and test, then we want to generate plan, tf plan dash out equals tf plan, calculate diff, and then we need a human to make sure we're not deleting prod. So human architecture review, you're basically going to check the diff and plan output as a PR. Approve the logic, and then finally the scary part is execute tf apply your plan, and then it's gonna implement diff. So that is how you do CI/CD with Terraform. Migrating between Terraform versions. How do you migrate between Terraform versions? Always upgrade one major version at a time. You must progress through each major version. Do not skip anything. Keep running Terraform plan. Ensure there are no changes. And consult the change log. It's pretty simple. What are TF modules and how do I use them? So let's grab one of these, make a purple. Terraform modules. So Terraform modules are basically reusable functions for your cloud infrastructure. So just as you use functions in programming to group code into a single callable unit, use modules to group related Terraform resources like a VPC, security groups, EC2 into a single package. That's pretty cool. So you can basically logically organize resources, networks, instances all into one package. Standardize your modules, work consistency, high complex config. Use variables, customization, keep modules focused on small pieces, manageable pieces. Let's make that bigger. Hey, this is starting to look pretty good, I must say. We need to work on the spacing a bit. I don't really like how this is going right here. That looks strange. This is actually a bit too big. Just move that there. Maybe we can make this like really short. Everything that's done is already under the sun. I might just extend this as part of the same question. This can come in a bit closer. More closer. Just move up a bit. That is right, boys and girls. I take great pride in whatever I'm doing right now. You don't think make things pretty, like why are you even doing it? What's the point? I am quite satisfied with this. I really hate what's going on down here though. It just doesn't work. You know why? The information heavy ones should be at the edges. And that does not look good. Okay. That's about as good as it's gonna get. 3 more questions. 3 more questions. That's it. And then we're done. And then we're free. Free to do other DevOps tools. So not really free at all, if you think about it. How do you create resources from different cloud providers? So there is a concept within Terraform, which is called providers. And there's also provider APIs. So let's ask Gemini, how do you create resources from different cloud providers in Terraform? Terrafork. Okay, so you basically have providers, but then you also have this concept of, also this technically okay, it can be purple. It's kind of Terraform. Let's zoom in more. Then you have like aliases. Alias, which is basically you use aliases to differentiate between providers. I'm just gonna line break that. So in other words, you have a main provider. So for example, let's say your default provider is AWS, because what else would it be? What are you, a schmuck? Use Azure? Oracle Cloud? GovCloud? No. We use AWS around here. Okay? Glad we're on the same page. Thank you so much for being understanding. And so in general, Terraform is going to use your default provider configuration. And then when you need another one for different providers, you can use alias to differentiate between them. So in here, we can see that you have here this alias is saying West US, and assign resources to providers. We need to find a resource, use the provider meta argument, tells Terraform which provider configuration to use. State management, complex orchestration, authentication, all of it can vary. Let's see what the DevOps dude says about multi-cloud deployments.
How would you handle a situation where you need to create resources in both AWS and Azure within the same Terraform configuration? You explain that Terraform's provider-based model makes this relatively straightforward. In essence, you define multiple provider blocks, one for AWS and another for Azure, each containing its own authentication and configuration settings such as region or subscription details. And another for Azure makes this relatively straightforward. In essence, you define multiple provider blocks, one for AWS and another for Azure, each containing its own authentication and configuration settings such as region or subscription details. From there, each resource block specifies which provider to use, whether provider equals AWS or provider equals Azure RM, ensuring that Terraform knows which cloud environment to operate in. You could, for example, spin up an S3 bucket or subscription details. From there,
Authentication,
block specifies which provider to use, whether provider equals
subscription,
or provider equals Azure RM,
extra quotation.
and another for Azure, each containing its own authentication and configuration settings such as region or subscription details.
Region, configuration settings, etc. Let's make this bigger.
From there, each resource block specifies which provider to use, whether provider equals AWS or provider equals Azure RM, ensuring that Terraform knows which cloud environment to operate in. You could, for example, spin up an S3 bucket and an Azure storage account, all from the same set of .tf files.
Basically, you're gonna
This approach is useful for organizations
specify
adopting multi-cloud or hybrid strategies because you maintain a single code base and consistent deployment process, even though the underlying resources might reside on different platforms. It also means you can keep your workflows uniform, that is, planning, applying, pipelining, and version control.
Count versus for each in Terraform.
When would you choose count over for each and vice versa? You want to explain that count is a straightforward way to create a fixed number of identical resources, like spinning up 5 identical EC2 instances. It's concise and it works well if you just want to say count equals 5 and don't need to differentiate among those instances. On the other hand, for each is ideal when you have a set, list, or map of items, with each potentially needing its own configuration details. For example, if you have a map of subnet definitions where each subnet might have a distinct side of log or and
So count versus for each. These are meta arguments where numeric loop, basically numeric loop for creating identical resources. Use integer. For example, counts equal to 5 and relies on indexing of each resource in the array. So you gotta be careful. Make sure you use the right thing. Whereas for each use, this is a preferred approach. The preferred enterprise approach. Resource mapped to specific key. If you remove items, only that specific item is destroyed. Unique identifiers, keys haven't changed. Best for managing collection, unique items, slight differences, configuration. Make that green. So if you want to make like 20 EC2s and they're all the same, you go with count. But if you want to make like 20 EC2s and one is like, you know, 2x micro and one is like 5x large, and it's like different computing needs and different cases, then use for each. It's pretty straightforward. Now it may appear that we just have one question left, which is blue-green deployments. So we're not talking about Canary.
Could you walk me through how you achieve a blue-green deployment using Terraform? You answer by saying something like, to ensure near zero downtime, I start by provisioning a fresh environment, often called the green environment, while the current blue environment remains fully operational. I rely on the same blue-green deployment using Terraform. You answer by saying something like, to ensure near zero downtime, I start by provisioning a fresh environment, often called the green environment, while the current blue environment remains fully operational. I rely on the same Terraform configurations I use for blue, but I adjust critical identifiers like resource names, network subnets, or auto-scaling group labels to avoid conflicts with the existing infrastructure. Once Grain is up, I run a thorough validation process, which can include functional tests, performance checks, and security scans to confirm the new environment meets all requirements. After everything checks out, I switch traffic from blue to green using either a DNS update or a load balancer modification, which directs user traffic to the newly provisioned resources without causing downtime. Because the green environment is already active and validated, users typically experience no interruption during this transition. Finally, once I'm certain the cutover went smoothly, I decommission or repurpose the old blue environment by running Terraform destroy on those resources. This approach creates a safe rollback path.
You create two sets of resources, two auto-scaling groups, two target groups, one shared load balancer. Use a variable, control a target group, orchestrated approach, AWS code deploy, Kubernetes to handle the cutover. Interesting. Very interesting. Okay. So, can I like full screen this or something? F11. Nice. There it is. We answered all 20 Terraform questions. And let's do this. Let's do this. And let's also give it a light purple background. Wait, is this transparent? White? What? Oh, do I need to bring it to front? Bring to front. I see. Okay, in that case. Boom. There it is. Can we export it as a PDF or something? Export. That was a PNG. Terraform 20 questions. Put it somewhere. Wow. Here she is in all her glory. Is it like HD if you zoom in? Yes, it is. Alright. We're done here. It was a good run. Nice whiteboard session. My top fan has joined the chat. Hello, top fan. Thank you. I'm so tired and hungry. It was a good session. We did pretty good, pretty okay. How many other hand symbols do I know? You have this one. You have this one. Hello. Okay, that's enough. Thanks for tuning in. See you in the next one. Whoa. I clicked something. Okay. I think we're all good. Welcome to my ASMR video.